This lesson is for Unit 1, Matrix Operations, and this is Day 2 of Section 1. So today we're going to talk about matrix multiplication. So if I have two matrices and I look at their dimensions, I can tell if they could be multiplied if the middle dimensions are the same. So if A is an m by n matrix and B is an n by p matrix, they can be multiplied. And the result would be an m by p matrix. So if they do not match here in the middle, that means the product is not defined. We cannot do it. But if they do match, the resulting product will be in the size of the leftovers. So in this example, we're just going to determine whether or not the product is defined. If it is, we'll give the dimensions of the product. So here I'm looking AB, right? We're looking at AB for all of them. 4 and 4 are in the middle. So that matches, right? 4 and 4 match. So my result is going to be 2 by 3. Right? Those are the leftover numbers, 2 by 3. For part B, I look at my middle numbers, and they're 1 and 4. They don't match, which means this product is undefined. I cannot take A times B in this case. For part C, I don't have the listed dimensions, so I have to find them. This is 2, remember rows first, by 2. And this is 2 by 1. So I look here, my middle numbers match, which means my result would be 2 by 1. For part D, this is 1 by 2, and B is 3 by 1. So looking at the middle numbers, 2 and 3 are not the same, so the result would be undefined. So you go ahead and try these. You can pause it, and I'm going to show the answers. All right, for number 1, it was a 6 by 5 product. For number 2, since it was 1 by 3 and 2 by 1, it didn't match, so that was undefined. Now we're going to get into actually multiplying matrices, and I'm going to tell you right now, I absolutely love multiplying matrices. So what we're going to do is we're going to circle the rows in the first matrix and the columns in the second matrix. We're going to set up a new matrix with the dimensions of what the product should be. We're going to multiply each of the terms by its partner, for lack of a better word, and then add those pieces together, and the sum goes in the new spot based on what was multiplied. So if I was multiplying row 1 and column 1, it gets put in the first row, first column. I know this sounds confusing, but once you see it in action, it should be a little clearer. So we're going to find the product AB. I have 3 rows, right? Row 1, row 2, row 3. That's a row, that's a row, that's a row. And then I have 2 columns, right? Column 1, column 2. Those are my 2 columns. So my answer should have 3 rows and 2 columns. I'm going to be showing quite a bit of work here, so I'm going to make a nice big matrix, right? We have row 1, row 2, row 3, and then we're going to have column 1 and column 2. What I'm going to start doing is to go into row 1, column 1 spot, I'm going to take the numbers from row 1 and the numbers from column 1. The first number is -1, the first number is 4, so we're going to do -1 times 4. And then we're going to do plus the other pair of numbers. The second number was 5, the second number was 7. So notice we multiplied the numbers from row 1 by the numbers from column 1, and it went into row 1, column 1. Now I'm going to multiply the numbers from row 1 and column 2, so that's going to go into row 1, column 2. So that's -1 times -3, and that's 5 times 8. All right, row 1, column 2 went into row 1, column 2. So now I'm going to do row 2 with column 1, and that's going to go here for row 2, column 1. So that's 6 times 4 plus 2 times 7. All right, so I don't know if you could tell now what I meant by its partner, right? The first number multiplied by the first number, the second by the second. So now we're going to do row 2, column 2. So that's 6 times -3 plus 2 times 8. And then lastly, we're going to take our row 3 numbers and multiply them by each column. So that's going to be 0 times 4 plus -4 times 7. And that's going to be 0 times -3 plus -4 times 8. All right. And then just to do a quick check, make sure we didn't miswrite any numbers. The ones that we multiplied should be the same for this, right? It's column 1, so all of the column 1 numbers should have been in our parentheses there. All the column 2 numbers should match there. And then row 1 was -1 and 5, -1 and 5, 6 and 2, 6 and 2, and so on. So you could see kind of how this came about from here. And now we're going to work on doing the actual math. So we're going to do -1 times 4 and 5 times 7. We're going to do 6 times 4. Sorry. It doesn't matter what order we do these as long as they go back to the original spots. Plus 2 times 7 is 14. 0 times 4 is 0. Plus -28. And then for this column, -1 times -3 was +3. Plus 8 times 5 is 40. We have -18 plus 16. We have 0 plus -32. So then our final answer is when we simplify these numbers. So -4 plus 35 is 31. We get 43. I know I'm going in a different order now. We get 38. We get -2, -28, and -32. And that is the product A times B. All right, we're going to do another example of multiplying. This one I'm going to focus on, first we're going to do A times B, and then we're actually going to try B times A. So for A times B, I'm just going to real quick rewrite these. Just so I have them that I can write on them. Okay. So for A times B, try to use a little smaller here. Rows in the first one, columns in the second. We know they're both 2 by 2s. My result will be a 2 by 2. That's 4 times -4. And as you get more comfortable with these, you could even probably get to the point where you do 4 times -4, just write the -16 there. But because we're still learning, I'm going to keep showing you every step. All right, plus 1 times 1. We have 4 times -3, plus 1 times 2. We have 0 times -4, plus -2 times 1. And we have 0 times negative 3 plus negative 2 times 2. All right, so now I'm going to start to do some of that actual just algebra. That's negative 16 plus 1. That's 0 plus negative 2. That's negative 12 plus 2. And that's 0 plus negative 4. So the product A times B is negative 15, negative 10, negative 2, negative 4. So now we're going to look at B times A. So I'm going to rewrite my two matrices, but this time I'm going to put B first. So that was negative 4, negative 3, 1, and 2. And for my second matrix, that's 4, 1, 0, negative 2. All right. Actually, let's do a different color. So again, rows in the first one, columns in the second. So when we start this out, negative 4 times 4 plus negative 3 times 0, negative 4 times 1 plus negative 3 times negative 2, we have 1 times 4 plus 2 times 0, and then we have 1 times 1 plus 2 times negative 2. All right, so we'll do some math. We have negative 16 plus 0. We have 4 plus 0. We have negative 4 plus 6. And we have 1 minus 4, or 1 plus negative 4. So now this means my answer is negative 16, positive 2, positive 4, and negative 3. So you'll notice my answers are very different, right? So what that tells me is that the order we multiply matters, all right? If they tell you A times B, the rows from A have to be multiplied by the columns in B. If it tells you B times A, the rows in B have to be multiplied by the columns in A. All right, so the order we did them, even though it was the same two matrices, changed what our end result was. So you go ahead and try these. You could pause it, and I'm going to show the answers. All right, so for 3, we ended up with a 2 by 2 answer. For number 4, since this was a 2 by 3 and a 3 by 1, our answer is actually just a 2 by 1 matrix, and that was 81 and 37. All right, in this one, we want to find A times B. Now, normally I would ask you, if I was talking to you, what do you think would happen? What do you think is going to happen if we multiply all these numbers by a matrix that is a 0 matrix? And your guess would probably be right. Anytime you multiply something by 0, it's going to become 0. So when I do the multiplication here, I end up with 16 times 0, which is 0, plus 4 times 0, which is 0. So that first spot is 0. 16 times 0 is 0. 4 times 0 is 0. So that second spot is 0. 12 times 0, 9 times 0, 0 plus 0 is 0. And 12 times 0, 9 times 0, 0 plus 0 is 0. So when you multiply a matrix by a 0 matrix, the result will be a 0 matrix. This one's a little different now. This has a different name, right? And we'll talk about what that name is after we're done. So we're going to find the product A times B now, and I'm going to multiply these rows by these columns. So I know that my answer is going to have negative 7 times 1, which is negative 7, plus 4 times 0, so that's 0. I am skipping some steps now, guys. I hope you're okay following. If not, send me an email. Negative 7 times 0 is 0, plus 4 times 1 is 4. 9 times 1 is 9, plus 4 times 0 is 0, and then 9 times 0 plus 4 times 1. So what this gives me is negative 7, 4, 9, 4. And if you notice, this is the exact same matrix we started with. That's because this is called the identity matrix. Right? Any square matrix with ones in the diagonal going from top left to bottom right is called an identity matrix. So a square matrix is when the number of rows and columns are the same. So you could also have an identity matrix that's a 3 by 3. Right? So now the column going down from left to right is ones and everything else is zeros. This is also an identity matrix. They're going to come in to play in a larger role in our next lesson. All right, and that's it for day 2.